Happy New Year and welcome to the very first SMPTE Now educational webcast of 2013. This month's topic is closed captioning challenges for IP video delivery. And this PDA Now webcast is brought to you by our sponsors, AJA Video Systems, Blackmagic Design, and Ensemble Design. I want to express our appreciation to their support for allowing us to bring this educational event to SMPTE members free of charge. I'm your host, Joel Welch, Director of Professional Development for SMPTE. Today's guest speaker is Jason Livingston. Jason spoke at a recent SMPTE technical conference in Hollywood on Captions, and he's agreed to speak to us again today. Jason is a developer and product manager for CPC Closed Captioning. And Jason, people did come to hear you and not me, so without further delay, I'll turn the floor over to you.
Thank you very much, Joel. I hope everybody can hear me okay. Can you hear me? Okay, good. Just wanted to make sure. Okay, thank you very much for the introduction, Joel. Thank you, everybody. I will try to speak a little bit quickly because there's a lot of good stuff I want to show to you. I will try to stop after every slide or two for brief questions, but we'll definitely have questions time at the end. Without further delay, here we go. So the topic today is closed captioning for IP delivery. Just a little bit of background of what exactly does that mean. There are now new FCC regulations in the US, and there's also CRTC in Canada as well, that require closed captions from TV broadcasts to be available when these videos are delivered over the internet, such as streaming on the web and mobile devices. And so if a program was required to have closed captioning when it was broadcast over the air, it will now be required to have closed captioning if it is shown on the web as well. It does not yet apply to web specific productions that are not shown on broadcast TV, but that may happen someday. And so to address a number of the challenges that I'm going to go over today, SMPTE created a new closed captioning specification called SMPTE Time Text, or SMPTE 2052, those are interchangeable, to try to address some of these challenges of bringing the closed captions from broadcast TV to the IP versions. And just a quick note, why is closed captioning required? The reason most people do it is because it's the law. Most programming on broadcast TV now is required to have closed captioning. I hate to say it, but unfortunately, that may be the only reason some people do it. There are good reasons, however, even if you're one of the few exempt programs that's not required to caption, there are more than 48 million Americans who have some degree of hearing loss. I got this official number from the National Association for the Deaf, and they would like to use closed captions. The closed captions are also very useful in noisy environments like gyms, restaurants, airports, etc., where you can't hear what's on TV. And I forgot to put in this bullet point, but a couple other points. If you have kids at home, closed captions are great for watching TV late at night, so you don't have to turn the sound up. I do that myself. And closed captions are also used by people who are learning English or maybe French or Spanish as a second language. And oftentimes reading the captions helps you to better comprehend what's being spoken, especially if it's fast dialogue. So those are really good reasons to caption, even if for some reason you are not required to do it. And there's a question, broadcast TV but not cable. Most of this does apply to almost all cable channels as well. Right now, the FCC regulation applies to pretty much everything except for the very smallest stations and some late night only stations. So what are the FCC requirements for the new IP captioning rules? Well, the IP closed captioning must substantially replicate the look and feel of TV broadcast captions, including the formatting and positioning that was used for broadcast TV. This is a really important point that cannot be glossed over. I'm going to go into a lot more details on this in the coming slides. The IP video players, this is any kind of mobile device or browser or software that plays video via the internet, is required to implement the same user controls that the FCC requires for digital televisions. Any TV sold in the US has certain requirements as to what controls the user has available, including the ability to change the size of the fonts, changing the color of the fonts, etc. And those same user controls will be required for any mobile device or IP-based software player as well. And another thing the FCC decided is that SMPTE time text is specifically singled out as what they refer to as a safe harbor format. I get a lot of questions. People ask me, what exactly does safe harbor mean? And I'm not a lawyer, so this is not a lawyer's legal interpretation. But my interpretation that a lot of people have agreed with is that if you imagine a chain of broadcast, each link in the chain is a provider, a content creator, a content provider, a content distributor, end user, etc., etc. Considering your link in the chain, if you accept SMPTE time text on the input side, if you're receiving those from the source of the video, and you deliver SMPTE time text on the output side, and both of these are adhering to the SMPTE time text specification, then you're considered to be in compliance with the rules, even if some problems occur. If it was something about the SMPTE time text specification, the formatting wasn't exactly right or something, you're basically exempt from some of these requirements. That is a pretty difficult rule, and I'm not going to go into too much detail about all the implications of that, but I will talk about it in the coming slides. Of course, what this really means is that if you are not using SMPTE time text, if you're using some other format, then the safe harbor does not apply to you. And if there are problems, you may be failing to meet your mandated requirements. What are the deadlines the FCC has set up for this IP captioning? The IP closed captioning rules apply to any non-exempt full-length programming. So if your video is exempt for captioning when you broadcast it on over the air or on cable, then these rules do not apply. But that is a very small and shrinking segment of video. These rules apply to most broadcast video. The deadline that is already passed is pre-recorded programming that is not edited for internet distribution. Must be captioned if it is shown on TV with captions after September 30th last year. This rule is already in effect. The question is, what does not edited mean? It's a little bit fuzzy, but I can tell you for sure that taking a few frames out of the video here or there, or removing commercials or substituting commercials, does not count as edited. Those are not exempt. But certainly if you made heavy editing to the show, that probably would not fall under this previous requirement. Pre-recorded programming that is edited for internet distribution will have to be captioned if it's shown on TV after September 30th this year. So even if you do edit it, you've only got 8 or 9 more months before that rule applies to you. And the big one that I'm going to be talking a lot about today, because it is the soon up-and-coming deadline, is that live and near-live programming must be captioned if it is shown on television with captions on or after March 30th. That's just 2 months away almost. Near-live programming is video programming that's performed and recorded less than 24 hours prior to the time it's first shown on television. So this is the big one a lot of people are concerned about. And I don't blame them. This is definitely a deadline to be worried about, and this is what I'm going to talk about a lot in this presentation. So I get this question a lot. Why is closed captioning so complicated? Yes. Yes.
We do have a question.
Can you hear me?
Do you believe that IP distribution, like YouTube, will eventually be subject to these rules?
That's a very good question. It's very hard to predict what the FCC will do in the future. The FCC right now does not have legislative purview over YouTube because YouTube doesn't have anything on broadcast TV. The FCC can only make mandates that apply to broadcast TV. My understanding is the reason they can get away with these internet requirements is that it's not the internet that they're regulating, it's the broadcast TV that they're regulating. So if your show is on broadcast and it's required to have captions, if your web version does not have captions, then it's your broadcast show that the FCC can penalize, that they can declare non-compliant. But if it's something that's only shown on the internet for now, they have no jurisdiction over that. That could change in the future. I can't really anticipate it. Certainly there are some groups that would like to see that happen and some other groups that would not like to see that happen. We'll have to see how that goes in the future. Okay? Back to the slide, I think it's okay. Why is closed captioning so complicated? It's just text and timing information. Well, it is, kind of, but the way closed captioning developed, though it was invented in the late 70s, it was first implemented in consumer products in the early 80s. They had to make a lot of clever engineering decisions to make closed captioning work back then. And because we're dealing with so much legacy content, those design decisions continue to affect even the new standards. We can't get away from the old standards. So back then, of course, you know, all video was analog, it's low bandwidth. The television was stateless, meaning you can flip to any channel even in the middle of a show and start receiving that show, start receiving the captions. It's not like you have to wait for the next show to start to see it. Of course, back then, computer power, digital power was extremely limited in consumer products especially. One of the good things that they added to closed captioning, the original spec, is a smooth roll-up animation that enhances comprehension and makes it much easier to read, especially with live programming. And I'm going to show that. They had support for multiple language tracks, support for limited text formatting and positioning around the screen. This is incredibly important and something a lot of people don't understand about closed captions until you've actually looked at them or created them. The character set for closed captioning can support most Roman alphabet-based languages, plus some accented characters for French, Spanish, Portuguese, etc. But it does not support Chinese, Japanese, Korean, other Unicode languages. That was pretty much unthinkable back in the 70s, 80s. Technology just did not exist to do that. And of course, there are a lot of limitations at the time when the closed captioning was invented. Like as I mentioned, very limited processing power, limited memory. They had to encode the signal in a way that would not interfere with all the installed base of televisions out there. Of course, at that time, we only had NTSC to worry about. Only 2997 frames per second. We didn't have all these HD frame rates that we have now to worry about. Because of the limitations, the character set, font size, background color, etc. were fixed in the spec. They cannot be changed by the caption author. And here are some visual examples of what the closed captions can do, 608 spec. I'm going to put my pointer on so I can point to some things. Hopefully you can see that. So, for example, if there's a lower third in the picture, you need to move the captions around so they don't obscure important parts of the picture. Notice the text has different kinds of positioning and justification. You can have split captions, multiple windows on the screen at the same time, like here and here. Here's an example of different kinds of special characters and positioning you can do. And the roll-up, the smooth scrolling animation. I wish I could show it to you animated, but it doesn't come through the webinar very well. You just have to imagine that this is smoothly scrolling up the screen. That's quite an achievement back for early 80s technology. You know, think about the state of computers back then and being able to draw things on top of a TV signal. That's not easy. So what about 708? We hear a lot about 708. I get a lot of questions about it. 708 is a new spec that they created along with the switch to digital ATSC broadcast. It adds a lot of new capabilities, but it also preserves backwards compatibility with all of the old capabilities of 608 captions. And some of the things it adds are support for more languages, Unicode characters. Although I have to say that although this exists in the spec, I have yet to find a single device that can play this back correctly. So almost nobody uses this feature because there simply is no way to see it, to actually use it. You can have more simultaneous languages. You can have proper support for frame rates other than 2997, like our great HD broadcast frame rates. Full 16:9 positioning of the captions using the full width of a 16:9 screen. The captioner can specify font styles and more formatting choices, such as the background opacity, font edge decorations like drop shadow, etc. And very importantly, 708 carries 608 backwards compatibility bytes, so that if you have a tuner and you're still using an analog television, that TV will still be able to display captions because the data that television needs is included as part of the 708 high definition caption data as well. But 708 has some drawbacks, so we're still stuck with a lot of the limitations of 608 anyway. For one thing, a lot of captioning software out there still only targets the 608 spec. There are various reasons for this, not just the maturity of the software, but also training of the captioners and the need for backwards compatibility. The common caption interchange files, the kind of files that captioners exchange between themselves and their clients, they only contain 608 data. They do not have a specification for 708 data in a common interchange file. So there are vast archives of closed captioning files out there that only contain 608 data. They do not exist as 708. The primary language captions have to be backwards compatible with 608, so you can't make use of things like Unicode characters, right to left text order, vertical text, etc., because those could not be represented in the backwards compatibility bytes that are mandatory. Like I said, there's a lot of hardware and software out there that just does not really implement the 708 spec as well as we would like to see. So the result is that if we try to make use of these great new features, somebody checks it on their QC equipment and says the captions don't work, and you have to go back and turn off all the cool features. Unfortunately, we're still in that state right now. So as a result, most broadcast workflows continue to use 608 captions for most of the process. And it's only at the last step before this thing goes out to air or goes out to the cable plant that there's a device that takes the 608 data and translates it to 708 data. So you do have 708 data, but you're only making use of the 608 features. And that's where we are today. So, of course, moving on to web delivery, what everybody wants to know. The streaming video needs to replicate broadcast captions as closely as possible. One, so that people who rely upon them do not get a second-class experience, and two, because the FCC has mandated that. So obviously that's very important. There are some, of course, existing efforts for web captioning formats before SMPTE time text came around, but none of them quite fit the bill yet. There are some common ones you may have heard of called SAMI, SMILE, and SRT. These formats do not support all of the 608 features. They cannot replicate all of the positioning and whatnot that broadcast captions have. So these are not suitable for meeting your FCC requirements. They just can't do it. Another very common one that used to be called DFXP, it's now called TTML, Time Text Markup Language, is from W3C. And that's a very rich, very full-featured language. It could replicate all 608 features. But what we found is a lot of players that claim to support TTML files or DFXP files, they support only a very limited subset of the specification. Maybe they don't support positioning at all. They can have text come up at the right time, but there's no control over the positioning or the formatting. So in theory, this would work, but in reality, they don't support all of the features that you're mandated to support. And finally, what some people have decided to do is to actually make their IP-based player support native 608 or 708 broadcast closed captioning data. And that makes it very convenient in that you don't have to worry about are you supporting the whole specification or not. But this is really not a trivial task. 608 and 708 are pretty tricky to implement. It's not even a free spec. You have to license the spec. So there's a lot of web developers that just don't want to get into this. They're not experts at broadcast engineering. They don't want to have to implement 608, 708. And furthermore, on the web, we have a lot of different video container formats. Some of these do not have a place designated to receive 608 or 708 embedded data. So there's no specification for how to put that data in certain container formats. I may have neglected to mention previously, just one of the reasons why this web stuff is so complicated. When you're talking about broadcast TV, there's a single specification, well, or a group of specifications, the ATSC spec. Every television follows that spec. Every broadcaster follows that spec. There's one spec to follow. That makes things easy. On the web, it's kind of like the wild, wild west right now. We don't have one specification for video on the web. We have a lot of different specifications. Different vendors like to support different specs. So they like to use different things. And one of the jokes I like to use is that somebody says, oh no, there's 10 specifications out there. We need to create a new specification to unite everything together. Well, now we have 11 specifications. So that part is not getting any easier, really. So as we move to captioning for the web delivery, what kind of features do we want to have in a new caption format? This is what SMPTE was pondering as they created the SMPTE time text spec. Well, it would be really nice to have a mezzanine format that is a single caption file, one master file that works for both broadcast and IP delivery. None of the other caption formats that existed so far can make that claim. Because the file would have to include both the raw 608, 708 data that broadcast televisions use, and it would also be desired to include a more easily processed format for the web-based players to display. Of course, whatever new format, it has to work together with existing authoring tools and standard practices, otherwise nobody's going to make use of it. It has to support both live and VOD post-production transmission. It's not very useful to have a spec that does one but not the other. It ideally should be format agnostic, which means, just like I said, there's a lot of different video codecs on the web, different wrappers, different container formats, different streaming protocols. It would be nice to have this caption format be agnostic of what is being carried in. And it works both as embedded into the stream, meaning it's actually embedded into the video data, and also as a sidecar file format if your video streaming format doesn't support embedded metadata. You can transmit the captions out of band, and I'm going to demonstrate that in a little bit coming up here. And obviously, of course, a new specification has to address all the FCC and other legal requirements for closed captions, including the mandated user controls, all of the other regulations. So, you know, SMPTE decided to use the time text markup language, TTML, as a base and expand upon that to create SMPTE time text. And I think they did a great job. But TTML spec and 608 spec work very differently. They're very different approaches to the same problem. We may someday have caption authoring tools that target native TTML for authoring, but right now most of the captioning tools that broadcasters use target the 608 spec, as I mentioned before. It's a completely different way of thinking about things, and I'm going to show that why. To understand a TTML file, you have to parse the entire structure of the file. That means you have to download the whole file first and have it available. That's a problem for live streaming, of course, because you can't download the captions for the whole show before the event has happened. But SMPTE did address that. And fully conveying all of the look and feel and properties of the 608 captions in TTML used to require very verbose syntax. You had to repeat a lot of information. It made the file very long, very wordy, to get all of those formatting and things to look identical to 608. And SMPTE addressed that, and TTML is addressing that as well. Just to show you kind of what the methodology looks like, what the difference is. 608 data is transmitted as a binary stream. There's no specified starting point or ending point of a stream. It's a continuous stream. A decoder can jump into this stream at any point and pick up the caption data right away. It's a stream that has a mix of both commands and information, mixed command and information stream. And so you can see in the representation, some of these data bytes are commands that tell the TV what to do, and some of them are text, what to display. And it's almost like a programming language. To understand how this works, you have to understand the memory model inside the television and things like that. So great for video engineers, not so great for web developers. On the other hand, TTML, time text, or SMPTE time text, is XML. It's pretty much human readable format. You can look at this right away and get an idea of what this means. But implementing the decoder is the tricky part, making it understand how to make this look like the 608 caption did. So now I'm going to spend some time on challenges specific to live broadcast. If there's any quick questions before I jump to this new topic, anybody want to squeeze them in now? We'll definitely have time at the end for questions too, so I'm not seeing anything come up in the chat window. The challenge is specific to live broadcast. I need to explain first, how do live broadcasts get closed captioned? It's not a trivial problem because people can speak very fast. Right now, I'm probably speaking around 250 to 300 words per minute. If you get a talk show, like a news show, sometimes it can be up to 350 words per minute from a fast speaker. And the best typist on a regular QWERTY keyboard can get maybe 100 words per minute, but not for a long time, not sustained, for hours on end. So you can't really caption something on a regular keyboard. You just can't keep up with the speaker. So the two options, one is something called a real-time court reporter. They use a special keyboard called a stenograph. So sometimes they're called stenographers. And just like you may have seen in a courtroom drama, they can type extremely quickly, but that skill takes many years to learn. It's not something you can pick up right away. So they do charge a lot of money for their services. Also, new technology, there is some captioning done using what's called a voice captioner. It's not a automatic black box that takes your program and captions everything. If it was, then captioning would be trivial. We wouldn't have to worry about it, but it's not there yet. The way that works is that the speech recognition software has to be trained to a specific speaker's voice in order to get good accuracy. And so a person would sit there, and just like a court reporter would listen and type what they hear, a voice captioner listens and repeats what they hear. And this is for live broadcast. Of course, for post-production captioning, you'll probably have a script and there's no time constraint, so it's much easier. But for live captioning, if you don't have a script, if it's ad lib, ad hoc, then somebody's got to be entering it in real time. Yes, if you have a news production system with a teleprompter or a script, there are systems out there that will take a teleprompter script and turn that into live closed captions. So that makes that a little bit easier if you do have a script or a teleprompter. The way captioning works is that the real-time captioner gets the video feed, they create the captions using whatever method, and what they send to the TV station or to the encoder, and the encoder is a piece of hardware that sits at the TV station, this thing here. What they transmit to that encoder is 608 data. There isn't any real-time captioning systems that sends 708 data. So they just send 608, and the encoder internally translates the 608 up into 708, embeds it into the video, and out it goes for TV broadcast, out to air, or out to the cable plant. So the first challenge for internet IP video captioning is, how do we get the closed captions from that point, from the CC encoder at the broadcast station? How do we get those to the internet? It's trickier than it sounds. Because now typically when you're streaming on the internet, you have something called a content delivery network, or a CDN, because they can handle a lot of bandwidth. They can send out many streams at the same time. If you have a small station, a small network, you might host it on your own website, but most of the medium or larger ones use a CDN. So how do you get the captions to the CDN in real time? Well, that's an issue because not all CDNs have support for that. Remember, they might be set up to receive video, but they don't understand closed captions. There needs to be some kind of a port, a delivery mechanism, by which you can stream the captions into the CDN. Not all of them have that yet. And even if they do have that, what formats do they support? What are you streaming to the CDN? Are they taking 608, 708 data, or are they taking something else? If they're taking something else, can you generate that in real time? And even if you can, how does that get from the CDN to the end users? I'll bring that up in the next slide. And very important, do these formats support all the FCC mandated features for captioning? It doesn't do any good if your CDN supports some kind of captioning format, like a plain text format, because that doesn't implement the FCC mandated features. So even if they claim to have support for closed captioning, does it meet your requirements? Maybe not. And of course, how does the CDN pass those captions on to the end user, the viewers at home? That's another technical challenge I'm going to mention in a bit. So different ways of addressing these challenges. One way is called in-band transmission of closed captioning data. This means the closed caption data, whether it's 608 data or SMPTE time text or something else, it's embedded directly into the video stream. Some video codecs and some video wrappers have the ability to store metadata, live metadata, along with the video stream. So in this case, it's not too bad for the encoding side, right? At the TV network, you have to encode your broadcast video into a web-friendly codec like H.264, and this encoder will need to preserve the closed captions. It needs to take the 608, 708 feed from your broadcast equipment, and it needs to do something with it. I don't know exactly what something it has to do. It depends on the situation, but it needs to preserve it or convert it somehow so that this video is sent to the internet or to the CDN. And then the CDN needs to deliver that video stream with the embedded CC to the playback software, the mobile device that's playing this. The challenge there is, does your CDN support this embedded data? Can your encoder generate this embedded data? And can your playback software, your playback device, understand this data? Can it display this data? That's not always the case. Another type is called out-of-band transmission of the closed captioning data. This means instead of embedding the captions into the streams, you would send a separate stream of information to the CDN. So it's going over two different channels essentially, but it's the same idea as before. You're delivering the video and you're delivering the captions to the internet, and then the CDN is distributing those to the end users. And again, the end user device or software, it has to be able to pick up on that data. It has to know that the closed captions exist. It has to, download them in real time, and it has to have a way to display them to the end user. The user has to have a way to turn them on. Not all devices do that, and that's a problem. And I think you'll notice in the next coming slides, a lot of times I'm saying that's a problem, and I'm not necessarily offering a solution for that problem. I really wish I could, but there's some reasons why I do not have a magic button that solves all these problems. I am very interested in solving them, so I would like to speak to anyone who's interested in helping me solve those issues. But I'm just bringing up the problems as they are now. So here's the second challenge. In an ideal world, yes? Yes?
Yeah, yes, we do seem to be experiencing significant latency in our audio as we've experienced in the past, so I'm going to try to manage it. But Tom has a comment or a question. Can you read that in the text chat box?
Yes, comments on CDNs that provide ports for closed captioning. I'm not going to mention specific names right now. I can tell you that I would expect, because this is such a big deal, most of the larger CDNs have already implemented some kind of solution, or they are in the midst of implementing a solution. I would also expect there are some smaller CDNs, or maybe CDNs that are not targeting the US broadcast market specifically, may not have this on their radar yet, and that's a problem, obviously. So you would have to contact your CDN or CDNs that you're considering using and figure out these pieces of the puzzle. Okay. Okay, I'll continue, but again, feel free to drop in a question if you have a specific question to these slides. I hope everyone can still hear me okay. So, in an ideal world, we would have something close to TV broadcast, meaning that every device out there receives the broadcast in the same way. Every television receives the same spec of video. But that's not true on the web. We have a lot of different web browsers, different kinds of plugins to the web browsers, different mobile devices, and those mobile devices have a browser. They may have separate apps on them. Also set-top boxes and tablets and other kinds of things that haven't been even imagined yet. Unlike TV broadcast, they don't all work the same. They all have their own specifications for how they want to receive and how they display video. If we had a perfect world, maybe all of these devices would support SMPTE time text, and that would make things pretty simple because the CDN or the server simply needs to convert the closed captions into SMPTE time text and get those delivered to the devices, and then the closed captions would just work for everybody. That would be fantastic. Unfortunately, we are not living in that world yet. Yes?
I'm sorry to interrupt. Donna has a question. When you said closed caption embedded in video, does this relate to metadata?
Pretty much, yes. Metadata can be a lot of different things. Closed captioning is certainly one of those things. Closed captioning is almost always thought of as metadata part of the video. Although, as I said, sometimes it's out of band, meaning it's not actually embedded into the video. But yes, definitely.
Next question from David. Would it not be better to require that the web video player have the closed caption controls rather than the device?
That is a very interesting question. I like that question. It's complicated. In theory, yes. But that's not how a lot of these devices work. Some devices, when you watch video on them, what you really have is a web browser with some kind of plugin in the web browser that's displaying the video. And the web page, you know, the JavaScript and all those things on the web page can have some influence over the video. But there's other devices that don't do that. When you click to play a video on this device, or some devices, you're actually exiting the web browser and going into a different video player software. So now the web controls have no interaction with the video whatsoever. So you might have some HTML5, some JavaScript that displays captions over the video, and it works great in your desktop web browser. But on certain devices that play these videos outside of the browser, there's no captions whatsoever because HTML5 and JavaScript do not exist in this video player. So the answer is usually no, but it could be yes. That would certainly make things easier. But not all web browsers do that. Not all devices play video in the browser. Think about a set-top box, like some of these neat devices you can buy that play from various streaming providers. They may not be based on a web browser at all. They have their internal operating system and their internal way of streaming video. And so that device has to support closed captioning and it has to support user controls. Otherwise, that device is not compliant with the new regulations. And I see another question popped up. Is HTML5 708 compliant? That's another very good question. Did I get that one? Yeah. So, in theory, it could be. You could, if you wrote a very nice JavaScript decoder, you could implement all of the 708 features to make it 708 compliant. I have not seen anyone who's actually attempted that or achieved that yet. Maybe there is, but I just don't know about it. So it could be. But again, some devices, when you're playing a video, it's not a web interface. So HTML5 does not come into play because there's no JavaScript going on. There's no HTML going on. All right. If more questions come up, I definitely will get to them. But let me move to the next slide. So as I was saying, the real world that we currently live in now, different devices support different kinds of captions. So you may not be able to simply deliver one kind of caption. You may need to deliver the captions in multiple formats to target different devices. There may be some devices out there that don't have any closed captioning support implemented yet. And there's really nothing too much you can do about it unless you are a app developer for that mobile device. You know, that's a problem, but I don't have a solution for that. I don't think anybody does. So another potential issue, this is something that has been occurring and we want to put a stop to it, is that SMPTE time text and the TTML that it's based on is a very rich, very full-featured language. There's a lot of stuff you can do in that spec that's not related to 608, 708. There are also multiple ways to achieve the same goals. You know, no two programmers are going to implement things exactly the same way. So what we do see now in the real world in some cases is that a SMPTE time text file, it's perfectly SMPTE time text compliant. It doesn't violate the spec in any way. It may work on some devices, but not on others. Whereas a different SMPTE time text file, which is also spec compliant, works on device B, but not device A. So this is a kind of a nightmare scenario, but I have seen it happening. You may need to deliver, even if you're delivering SMPTE time text, different SMPTE time text files to different devices. The good news is that there's a big industry push to solve this problem, to have a more uniform set of agreed ways to do things in SMPTE time text. There's something called a simple delivery profile that's being worked on to try to unify all of this. So hopefully this problem will not continue, but I wanted to bring it up because it does exist in the real world. And I see there was a question about the license requirements of 708. 708 can mean two things. 708 can mean the actual binary data that the 708 specification tells you to use. And I think that would require that you get the specs from CEA. It's not free. But 708 in kind of general talk is understood to mean the kinds of positioning and formatting that you can do in the 708 spec. And I don't think there's any kind of license requirement to make it work like 708. So to use the actual raw data, maybe, but to emulate 708, I think you're fine. I'm not a lawyer, but probably you're fine. So as we were just discussing a little bit, how do we display the closed captions in the user's browser or the user's device? That is also a challenge. Ideally, all devices will eventually support one or maybe two different specifications, probably SMPTE time text and 608, 708 for some devices that choose to implement that. But that's not the case yet. We got a lot of devices out there that have decided to use something else. And I hope those developers understand that if you're not doing SMPTE 2052 and you're not doing 608, 708, you're not covered by that FCC safe harbor provision. So if the captions don't work, you could get in trouble over that. Whereas if you use SMPTE time text, my interpretation is that even if things are not perfect, you're considered in that safe harbor provision and you won't get in trouble. So what some of the larger broadcasters have decided to do is that they want to target devices that don't support their preferred closed captioning format or their preferred codec or their preferred delivery mechanism. A workaround is to create a custom application tailored to view those streams. That's great if you're a big TV network. You will probably create your own custom app anyway for your TV channel because you want to control the presentation and the features of that app. But that gives you a lot of control over what caption formats you can support. But that involves a lot of work because you may need to create an app and maintain it for multiple devices. Think about some new device comes out that's completely different operating system from anything else. Now you have to pay somebody to create that, to port that app to that new device and to test it and make sure it works and to keep it updated, et cetera, et cetera. And because the app has to support all the mandated FCC features such as caption formatting and user controls, it is not a trivial task. It's quite complicated. Again, for bigger providers, that's probably not an issue. But for smaller providers, smaller TV stations, creating your own app and supporting it, that could be a major time and cost sink, and you may not want to go that route. But if you don't go that route, then you have to rely on whatever is built into the device, which may not be what you need. And a quick question about carriage of SMPTE time text is standardized in some of the IP delivery formats. Yes, I believe that's a solved problem. The way to transmit SMPTE time text embedded into certain formats, that is standardized. So what's the status of these challenges I've brought up? Well, not that great, unfortunately. What we need to see is more cooperation between the manufacturers of the streaming encoders, the CDNs, and the playback device manufacturers. Because even if each piece of this puzzle, if every link in the chain supports closed captioning, you put it all together and maybe it doesn't work. Because your encoder does things differently than your CDN expects, your CDN does differently than your playback device expects. So just because everything has a closed captioning stamp of approval on it does not mean that when you put the pieces together, everything is just going to work. And each entity has their own timelines, they have their own goals, they have their own corporate philosophies of what they will or will not support. So getting these guys to cooperate is difficult. If you are one of the entities I mentioned and you're interested in speaking with me about making this work better, please do. I would love to speak with you. So the current status right now is, like I said, many encoders support some kind of closed captioning. It might not be the kind your CDN needs. Many CDNs support closed captioning, but it may not support it for all the devices you want to target. And every browser, every mobile device, every operating system is at different stages of implementing different formats. Some of them are quite advanced, and some of them are definitely lagging behind. So I'm going to run out of time if I don't go super quick, so I'm going to blow through some of these last slides. We've been talking a lot about live captioning, but also there is post-production, or VOD is a concern. And often the videos are edited before they're put on the web. These are the videos that will require captions starting September 30th of this year. That is, videos that were edited, but they're not live. You know, after you edit a video, recaptioning it from scratch is very costly, time-consuming. Nobody wants to do that. Most of the NLE video editing systems out there do not understand closed captioning. Even if they do, they may not preserve it through an edit. So hopefully this is going to improve in the future. But if your editing system does not preserve the closed captions, you're going to need some kind of external tool, third-party tool, that can, for example, take the edit decision list from your NLE and use that to parse the captions, to reconform the captions to match the edited version. That way you can automate it. That way, if you make an edit, you don't have to have it recaptioned or manually edit the captions. You can have a fully automated system that reconforms the captions for the edited version. And those tools do exist today. Another real quick one I want to talk about, legal rights to the captions, because I've had some clients come to me very upset because of this issue. There are some caption providers out there, caption service companies, that when you farm the captions out to them, they do the captioning for you. Your contract with them may specify the captions are only licensed to you for TV broadcast. You may find out that you have a library of closed caption files that you are perfectly within your rights to use for TV broadcast, which you legally cannot use on the web because you don't own the copyright or the rights to those. It sounds bizarre, but this is actually pretty common from my understanding. Some of the TV stations I work with are understandably upset about this. So if you are farming out your captions to a third party, make sure that you are getting the rights and the licenses that you need, or that you own the copyright, so that you can use these captions on your IP video. Otherwise, you're going to be paying to do the same thing again. The National Association for the Deaf, the NAD, testified recently before the U.S. Copyright Office that closed captioning and other accessibility technologies should be exempted from copyright and anti-circumvention measures. That has not happened yet. I just want to be clear. They have advocated that. It is not a law yet. It's not even a bill yet, as far as I know. But hopefully someday this issue will kind of go away if that happens. And again, I'm going to run out of time, so really quickly, some recommended best practices for captioners. You have to stick with 608 for now for the reasons I mentioned. Post-production content, please try to stick to pop-on mode. I didn't talk about this enough, but roll-up captions that are kind of used for live captions or inexpensive captions, they tend to not work as well on IP-based players, video players, software players. Pop-on is also easier to read. It's much preferred by the deaf community who actually uses the captions. They would like to see more pop-on captions. Make sure you are providing the rights or the licenses for these captions to your client, because otherwise they're going to have problems later. Content creators. If you are authoring new content, if you author the captions in-house, you can eliminate a lot of the legal issues and technical issues that I've mentioned. If you're farming them out, ask for them to be done in pop-on mode, except for live. Try to store the caption information in a separate caption file. You can extract captions from a videotape or a video file, but typically that's more work. It takes longer. It's much easier to get at the original captions if you have them in a separate standalone file. And make sure you have in-house capability to handle all of your caption-related tasks. Content providers and distributors. There's a lot of conversion going on. You get a caption file in format X. You need to spit it out in format Y, probably SMPTE time text. Make sure you have software that can do that. It can handle a wide range of different kinds of caption files correctly. If you're doing commercial removal, commercial substitution, show segmentation, etc., the editing of those captions can be done with at least some automation. That's good news. Try to target SMPTE 2052, SMPTE time text, or at least native 608, 708 caption data for your distribution targets, so that you are falling within those FCC safe harbor regulations. Because if you're delivering something else, then somebody might point the blame finger at you when things go wrong. And for web and mobile device developers, if you haven't already, please try to implement a support for SMPTE time text, or at least native 608, 708 data, so that you also fall under those FCC safe harbor regulations. If you're supporting a different format, then if things go wrong, the finger points at you. Watch out for quote-unquote supported formats that don't do everything you need. You know, if your vendor says, we're giving you the captions as a SRT file, well, SRT file does not preserve positioning, formatting, doesn't preserve the animation. So just because you're getting a quote-unquote caption file does not mean that you are necessarily compliant with the FCC rules. You need to use a format that supports all of the FCC mandated features. And likewise for the user controls. This is a big one that I think is going to shock some developers when this happens. I think the FCC has put off the implementation deadline for some of the user controls. I've just heard about that. So again, I'm not a lawyer. We'd talk about that at another time maybe. But if you make a web app or a mobile device app for playing video and captions, it has to support those FCC mandated decoder features and user controls. And very quickly, conclusions before we get to the questions. So why is this so complicated? Because the original 608 spec was very cool, but also very complicated. And we're continuing to live with those design decisions. Even specs that came out back in 2005, 2006, like 708 captioning, are not fully implemented across the industry yet. So I don't think we're ever going to reach a point when we can say, okay, folks, closed captioning is done, everything's working, we can forget about it. I think there's always going to be new challenges related to closed captioning as new technologies come out. But once we see more universal support for SMPTE time text, that is going to be a good long-term solution for all of these requirements, both for broadcast and for IP delivery. So that is the long-term solution, and hope to see that happen very soon. And that is pretty much it for the slides. Sorry I had to rush through there, but I will try to pick up some of these questions. And Joel, if I miss any questions, please let me know. I'm just going to scroll up here and take a look. Pros and cons of having the CC embedded in a file versus a separate file. The pro is that you have only one file to deal with. You don't have to manage the assets as two separate assets. The con is that anytime you process that video file, you have to make sure that processing preserves the closed captions. Because if you transcode it, if you edit it, if you do anything to touch that file, if that system doesn't understand and support closed captions, the resulting file may have no closed captions in it. Whereas with a separate file, that's less of an issue, but then you have two different assets to track and deal with as separate assets. Status of the uptake of the 608 tunnel and 708 tunnel in TTML. 608 tunnel is fully implemented. So TTML, or I should say SMPTE time text, because this is part of the SMPTE time text spec, not the TTML spec. SMPTE time text supports the 608 tunneling, and the spec for 708 tunneling will be approved at some point in the future. Streaming to iPhone mobiles, usage of SRT files to comply with FCC regulations. Well, once the FCC gets more strict about these positioning and formatting requirements, SRT is not going to cut it. SRT strips out all of the formatting and positioning. If you look at an SRT file, it's extremely simple. It's got a timecode, plain text. Timecode, plain text. Extremely limited ability to control formatting and positioning in there. There is some work on other specs that do include that information, but at that point, maybe you should just use SMPTE time text. Is it FCC requirement to deliver closed captioning on commercials and promos? I believe that is not the case right now. Commercials and promos are exempt from closed captioning requirement because they are not full length. They're not considered full-length programs. However, as I said before, just because you're not required to do it doesn't mean you shouldn't do it. I think in North America, about 20% of households use closed captioning, either because someone is hard of hearing, or someone whose English is not their first language, or because you want to turn the volume down, or because you're at a restaurant or a bar and you can't hear it anyway. So just because you're not required to caption your commercials doesn't mean you shouldn't. It's a shame to spend a whole lot of money on a commercial and then, you know, essentially lose out on 20% of your viewer market just because you don't have the captions. I'll leave Joel to answer the question about the recording of this presentation. Real quick, what is SCTE 20 and 21? How does it compare to 608? SCTE 20 and 21 are specs mostly used in cable broadcasting. They concern how to put the 608, 708 data into the broadcast stream. So they don't tell you what the 608 or 708 is or contains, but they tell you how to package it into the stream. And there's definitely software that supports that I'm very familiar with. Where does one find the P16 code in CEA-708 spec? Contact me afterwards. I'll tell you the exact page number. How about that? Digital cinema subtitles SMPTE fully compliant. Digital cinema excuse me. XML specification has somewhat of an overlap with SMPTE time text, so it can be compliant. It depends on which direction you're going. If you're converting 608 to digital cinema, then as long as you preserve the same look of the 608, then you should be fine. If you're going in the other direction, some of the things digital cinema subtitles can do not translate to 608. But I don't think that's a problem going in that direction. I don't think it's a legal problem. What percentage of time text broadcast is 608 tunnel versus text? If you mean whether they use the tunnel or whether they use the text, really you should have both. You should have both so that the file can be used both for broadcast and for web-based players. I'm not sure if I understood the question right. If you mean in terms of the file size, the tunnel data does take up a lot of space. But you should always include it, unless you know that this file is strictly only for IP delivery only, and the 608 is not needed, then you can turn off the tunneled 608. All of the SMPTE time text converters I've seen that convert 608 to SMPTE time text, they give you the option of whether you want to enable the tunnel data or not. Whew. Okay. I think the marathon is over. Oh. One more thing came up. Does WebVTT support FCC requirements? It can, once they get that fully fleshed out and add a couple things to it that I've talked about. I think it will eventually do that. I'm not sure if it does right now. If you want to know more about that, if anybody has any specific questions related to what I talked about, my contact info is on screen. I would love to hear from you. And I think that's about time.
Very good. Thank you, Jason. Excellent presentation. I think the comments support that observation. We can talk further about a follow-up later in the year, as you and I did yesterday. I would like to thank our SMPTE PDA Now sponsors, AJA Video Systems, Blackmagic Design, and Ensemble Designers. And thank you to our guests. With that, we will close today. Thank you again, Jason. Thank you again to our audience. We will see you next time on SMPTE PDA Now.